speaker of the day, which I'm sad to say, but I'm excited to have him on, will be Dennis, and he's going to talk to us about LLMs versus LMS. LMs in product. I'll let him clarify that title. Hello, how's it going?
It's good, Lily. Thanks for having me.
Good, good. All right. Well, I will let you take it away. I'm very curious to hear all about this talk.
Great. Let's get started. So, hi, everybody. I'm Dennis. I'm the machine learning lead at Voiceflow, and I'll be talking a little bit about what we've learned working with large language models in production versus just regular old language models in production. So, agenda is pretty straightforward. We're going to talk about how we use large language models right now in productions. We'll then talk a little bit about the difference between large language models and large or language models. I get myself tongue tied. Talking about our existing use cases and some production deployment differences. So, a little bit about Voiceflow, because I think it's really important to establish what we're building, because you have to know what you're building and what problem you're solving before you just go deploy models left, right, and center. So, we're a company that's focused on helping you build chat and voice assistants. We're a platform, which means we're self-serve, meaning as a company, we need to make sure that our customers have all the tools they need to build these assistants themselves. So for our use cases, we've had this platform around for almost 5 years now, and around 6 months ago, we added some generative AI features, so large language models. We added use cases at creation time when you're actually building your chatbots and assistants, but also at runtime when you want to prompt chain or utilize large language models to create some kind of additional response for the user. So on the left hand here, we're creating some data to train our bot. And on the right hand here, we are adding a generate step that we have onto the canvas. So very different use cases, because creation time, it's not the end user facing one, it's for our platform users, and runtime is at the end. So two different use cases, but both pretty interesting for large language models. So we established this by launching our AI playground, where you can basically experiment with different types of language models for building your conversational assistants. So before we had this cool platform that we've built, now we're layering on the ability to prompt chain, add all these different AI steps, choose different models, but also mix it up sort of with more traditional chatbot and voice assistant building. So images, responses, you can mix and match. We also launched a knowledge base feature, which basically lets you upload data and return a response that's summarized by a large language model. So not only do you have to, you can manually create your assistants, you can also just do a quick FAQ creation of the data. So those are some of the use cases that we've built out. And I'm describing them not to necessarily promote the product, but for you to understand what challenges we ran into and how we solved them. So now, taking a step back, I want to talk about what a large language model is. And I have a fairly controversial definition. Um, the first question I typically ask people is is BERT a large language model, right? BERT came out in 2018. Was it a large language model? And people are usually like, hesitant. Maybe in the chat you can say if you think BERT is a large language model. Then we get into another model, FLAN T5, right? Is FLAN T5 a large language model? And then people are starting to say, okay, well, it's an encoder decoder model. It does some really cool stuff. And then you get to FLAN T5 XXL, which is an 11 billion parameter model. And it's like, okay, is that a large language model? So the way that I've defined a large language model is a way that it's a general purpose language model that you can throw a bunch of tasks on. And what I think it is something that's better than the original GPT. The 2020 release of GPT-3, where you can do a bunch of cool tasks, right? Summarization, generation, etc. So that's how I've defined it, because within our platform, you need to be able to support a bunch of different use cases, and to be able to do this for a bunch of different domains, because we support automotive, retail, banking, all these different verticals. So taking a look at all the benchmarks, right, and we get to one benchmark, MMLU, And we look at the data, and there's a couple of open source large language models that are better than GPT-3, right? So FLAN-T5 large, Llama, Flan family, Falcon came out, and there's a bunch of Llama derivatives. But basically, that's what I qualify to be a large language model, just for the purpose of generation and understanding, and typically how people are using them. So with that definition, this is why we use large language models, is for this generational ability across different domains and a number of different tasks. So I'll be using that definition and talking a little bit about the model sizes. So what's interesting is for large language models, typically you need multi GPUs to deploy this if you're using full precision, right? Falcon 7B actually can be deployed on one GPU fairly easily, but most of the other models, if you're trying to deploy Falcon 40 billion parameters at full precision, you need multiple GPUs, even the larger Llama models, right? Um, we've had a lot of interesting progress being made with quantizing these models. A couple of different talks probably talked about that, where if you're doing 3-bit or 4-bit precision, you could do it on a single GPU, an A100, for example. Now, integrating large language models with your existing infrastructure is challenging. We haven't done this integration ourselves. We've been using the OpenAI API for this reason, because we don't want to be running a fleet of A100s, and space is changing so quickly that you have 4-bit papers being released before it was 8-bit, right? Progress is going so quickly that we haven't invested into that LLM infrastructure because it's not core to our business. Our core to our business is giving these supportive features to our customers rather than doing the research and self-hosting side of things. So we've chosen to use an API, and that's how we integrated it. So we have the service that we use both for large language models and for language models. We built it out. It's called ML Gateway. It basically connects with our services, and for each of our models, we have an endpoint and a service. And for large language models, we do a little bit more. So same way that you would connect with a Voiceflow model, we connect for our generative functions. We just pass it through OpenAI rather than to our own infrastructure on the back end. And then we do some prompt validation, rate limiting, and usage tracking. So we use the same service for integrating it because we already built it out. It was convenient, just plop it in and replace the API. You might have seen already, we also have Claude in the platform, so it's the same thing, connecting to Anthropic, sort of in the same method. Now, with large language models, you typically don't get the same errors that you get with regular ML models because our ML models are encoder based. So there's no generation involved. It just gives you a class like this is what you're going to do, or it gives us an embedding. So very different problem space. So for us, it was a little bit new figuring out, okay, what prompt errors are we going to run into? So we use large language models to generate JSON, and that takes some time to figure out exactly what the format is because these models don't produce the cleanest stuff, right? So we had to implement some prompt engineering to fix this. Even then, it wasn't great, so we need some regex, just some handwritten rules to format it. I know this has changed. When was it? Yesterday, where the functions came out, but for us, when we were doing this integration work late last year, right? It's something that we ran into, and we had to test to make sure it was okay. So a couple different examples here, just JSON issues. So we actually can pass it back to our platform. And sometimes it's a little frustrating, right? Because you'd assume that these large language models are trained on correct data. You have all your prompts established, but still have some issues there. And the way we went through this is that we'd record all our errors that are coming in through parsing. We tracked metrics for all the different tasks that we had, and then we would occasionally run those erroring responses and prompts through other prompts that we created, and created this test suite that we would backtest. And if it worked well, we'd push to our prompt store. So this is an example of running one of these tests, right? You can see here where things would break, and then we would go ahead and modify those prompts based on those errors. Now, we also tried out fine tuning for some of these tasks for the formatting in our specific use case, but we noticed that it didn't actually improve too much. So we found out that because you can only fine tune the smaller models on OpenAI, we didn't get that same performance that we got with GPT 3.5 or ChatGPT or GPT-4. So while formatting wise, it was much better, we lost some of that answering ability. So this example here is a Q&A prompt that we had, and we saw decreased performance, so we didn't actually use the fine tuning in production. So another example here, we saw that fine tuning gave us an answer, but it was just completely hallucinated. But the full size DaVinci model worked all right. Now for fine tuning, we actually use generated data to fine tune the model in our experiment. We would pass in some documents, use some generation of the questions and answers, and then myself and other people on my team, we took that and made sure that the answers were correct. And then we fed that training data into the fine tuning process. Now, when we originally did this, ChatGPT, the API was not available. That came out in March, if I remember correctly. So we went through and redid the tests on ChatGPT. It was cheaper, but the engineering work to redo some of these prompts and integrations wasn't necessarily worth it. We migrated some models onto ChatGPT, especially all the new stuff, but not the old ones, because from an engineering perspective, as a company, we decided that it was working well enough, and refactoring that wasn't necessarily worth it. Now GPT-4 came out, and we're like, okay, this model's really cool. Should we try it out? We did. It was better. It was just way too slow for our use cases, so we abandoned it. We still let you use GPT-4 in our platform, if you saw that in the dropdown, but we try to provide the users some different guidelines. We've published articles, have those different materials to help users choose which model they want to use. And what we figured out internally is that it's actually fairly challenging to test large language models in production from a conversational perspective, right? We talk about ChatGPT giving responses and whatnot. So we started building out this large language model framework that we're continuing to iterate on and develop in house, just to make sure that we ourselves can write our own test cases. We can have both technical users and some of the less technical folks who are more hands-on with customers and understanding their use cases, write these test cases and be able to run them. And we eventually want to productize this as well. So something that we're looking at too. Now with large language models, it's interesting because there's that discussion of fine tuning versus using few shot. And there's a number of proponents of using few shot instead of fine tuning. And few shot is great. The challenge is that when you give a lot of examples, your costs go up quite a bit. So what we learned is that when running in production, you have to be careful in those prompt tokens, depending if you're using ChatGPT or GPT-4. To run a 2K prompt, which you get there pretty quickly with using few shot learning, depending on your task, it can be quite expensive. For GPT-4, you're looking at 6 cents per interaction. ChatGPT is still pretty reasonable, but you have to be very careful with that cost trade-off, especially in production with higher usage. The other thing that we ran into, this is a screenshot from Helicone, but we had similar issues, is that there's a lot of fluctuation between latency. So with our internal models, we saw that there's consistent latency, both ChatGPT as an API. We saw that there's quite a bit of fluctuation, inconsistency. P99s were pretty crazy at some point. So we decided to benchmark it and think through, okay, are we offering Azure ChatGPT or just regular ChatGPT? Found that Azure was almost 3 times faster for doing these kinds of tasks, and the standard deviation was also lower. So we found a much more consistent experience, but the trade-off is obviously in cost. There's an upfront cost for running that. So we didn't necessarily expect that these things would be at play. Well, we hoped they weren't, but because OpenAI and other LLM companies are growing quickly, their models are evolving, there is some instability there. So it's kind of difficult to tell your customer that you have an issue with latency or something else as a platform when it's happening downstream. If anybody experienced the AWS outage earlier this week, it's a little bit awkward, right? Because you can't fix your platform. It's just down unless you've invested in some much more mature multi-region, multi-model success criteria. So We've also experimented with different models. So we have ChatGPT, Azure ChatGPT, and we tried out Claude and Claude Instant, found some differences there. And it actually depends based on how many tokens you use. Don't have too much time to go into that, but something important from our end is just making sure that we can test out these models that as they're coming out and making sure that they fit the use case. We can't benchmark all the models because that's its own research task, but when we find that a use case matches, we'll try to benchmark and add it into the platform. Now, we get into the question about should we deploy our own models? And we as a company have been deploying our own models into production for around a year and a half now. And it's a trade off, right? So when we were using an API, whether for fine tuning or inference on OpenAI, we don't control our own infrastructure, right? So here you can see it took a little while to be in a queue and to actually fine tune the model versus when we run it ourselves, we get a lot more logs. It's a lot faster because we handle the platform, but it takes a lot more effort to build that out, and it certainly has trade offs. So now shifting into from our large language model use cases to our language model use cases, we have sort of four main ones: utterance recommendation, conflict resolution, clarity scoring, and our NLU model. So basically, these are designed around the process of building a conversational assistant where you want to see, is your data good? How do I get more data? And how do I have an actual good model that powers this chatbot or voice assistant? And what was interesting is that the first model we pushed to production was our utterance recommendation that we built in house. But when we integrated with a large language model, we actually deprecated that, especially with multilingual customers, especially with more and more domains. It just made sense to use a third party API, something that we weren't necessarily considering before, but it just made sense, right? And as a practitioner, it's like you made this model, it's your baby, it's running in production, but just got to deprecate it because it doesn't make business sense. You're not getting that customer value. Now, this certainly has a trade-off, right? I'll talk a little bit about how we deploy our language models. You have this option of just using it as an API, right? I called this. Talked a little bit about this first in January. I called this large language models as a service, and then Llama came out, and then now they blur together when you look at the acronym a little bit. But when you're using large language models as a service, right, it's very easy, or a lot easier. You send your data, or you just call the API, and it works. But it's certainly a matrix, right? Are you hosting your own model? Are you training your own model? Are you using your own data? There's all these different considerations to go into, and not as much time to talk about it, but you definitely need to make that decision of where you take this trade off. For us, you can see on the top right, we built our own ML platform that does our own fine tuning. We host it ourselves. We run inference. We actually let our customers train models in real time. So that adds an extra level of complexity. But we also use OpenAI, which is like in the bottom left. So you don't actually have to choose the same hosting solution for all your models. You just need to make sure it makes business sense, right? So we don't do things necessarily in the middle here. We've kind of taken an opinionated approach on either end. But as technology changes, as value propositions change, right, you have to always know what makes sense, right? So for example, if we're going to deploy a large language model, it might make sense to use a more managed solution rather than trying to wrangle like A100s for ourselves, or H100s, or whatever GPU requirements that we need. Now, it's interesting because you get into this conversation of, can LLMs do everything, right? And one of our primary models is an NLU model, which in industry, it's a little bit of a misnomer. Typically, an NLU is something for natural language understanding, but in the chatbot space, it's focused on the task of intent and entity detection. So intent detection, a user says something, you try to match to the class. So I want to order pizza, you match to the order pizza intent. Then entity extraction is that you might say a medium pizza or cheese pizza. It's kind of like a keyword and information that you want to get out of that sentence. So these models have been around for a while. There's several commercialized versions out there, and we decided to build one ourselves because it's part of our core business. Problem is that sometimes when you build your own models, you have these outages. You can see here like a spike in latency that we ran into, and that can be kind of challenging, right? Because prod goes down and everybody's like, why is prod down? Why don't we just use a managed service? And that goes into the consideration as well. So we made the decision to host the models ourselves because they're quite sort of custom to what we built. Um, but what ended up happening is the original architecture that we built to, if we go down to that list of four models, we started off with utterance recommendation and we had certain requirements. So we built it for pub sub architecture, where some of these requests might be a little longer running. We had an SLA of 150 milliseconds in each direction for P50s. So that was okay. And using the technology that we selected, Google Pub Sub for that, it worked out great. We got to do lots of cool things like schema validation, handle traffic, multi-region. That was quite good. But what ended up happening is when we deployed the Voiceflow NLU, this model that needed to do inference, we realized that with this PubSub architecture for our language model, right, we're getting too high P99s, right? It took too long for certain requests to come back, and part of it was based on the PubSub architecture. And it feels bad because you designed this platform, we built it a year before we wanted to deploy this model, and it worked great until it didn't. So then we had to do a refactor and a re-architecture. And what's interesting is that the actual language model had very consistent latencies, right? It was between 16 and 18 milliseconds. The language model had great response times, but PubSub itself, you can see here, the P99s got quite high in each direction of actually sending the message back and forth, right? So the P50s were great. You can see here, like 20 milliseconds, like 30 milliseconds in each direction, but you had those massive spikes because the tech wasn't built there. And we didn't actually know we were going to build this model when we were building the platform. So we had to re-architect. We had to use Redis as our queue and deploy it closer to our application layer. So that had some challenges there too. But we ended up doing it, hit our P50 and P99 targets compared to our earlier deployment. And we outperform a lot of the industry standards based on what we've been doing our testing on various data sets. A couple of competitors where we're doing quite well. So we invested in that language modeling capability because it was core to our business, right? It was something that we wanted to bring in-house. The question is, well, large language models are great, right? They're amazing. They're really cool. They can do all these tasks. So how do they compare to this custom model that you spent a lot of time building? Well, the first thing is that latency is quite high. That's one of the challenges. The other thing is that the accuracy and the cost just don't make sense. So our NLU model still outperforms GPT-4 in this one test that we did, both on cost and on accuracy. GPT-4 does a great job as a model. It's very easy to use, but it costs 1,000 times more than our model to actually do inference on. And this is only 3,000 inferences that you're running. So if you're going into production as a large company, it's quite expensive, right? So that's that. Large language models versus language models. Talked through a whole bunch of topics, but happy to answer questions. And if you have any more questions, you can always reach out to me by email or on LinkedIn.
Awesome. Thank you so much. And yeah, everybody who's watching, check out Dennis's email if you have questions. And we'll give it a moment in the chat. But I think maybe folks can reach out a little later because we're wrapping up. But that was awesome. How did you feel about the talk?
Yeah, I mean, it's always interesting with these talks, but feels good. I mean, there's so much to talk about on the subject. I could probably do like an 8-hour talk, but gotta
Yeah.
wrap it up at some point.
No, sometimes like the 10-minute talks, I can tell people are just like crunching all the information down and it's so hard.
Yeah.
Well, cool. All right. Well, thank you so much for being our final talk of the day. Definitely send Dennis your questions, and maybe Dennis, if you want to jump in the chat and see if there are questions there. And yeah, we're wrapping up. 2 days, I think 84 talks. It's been crazy.
Yeah. Thanks for having me. I'll jump in the chat and answer any questions there.
Okay, awesome. Thank you so much. Bye, Dennis.
Bye.